Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. So today we've got Sean who has completed the course ROS 2 Navigation. So he will be giving us a presentation on how he managed to do the project, and he will take us through his code base after a demonstration on the real robot. Then we will get into some questions as we go along. So I will now hand over the floor to him so that he can begin his presentation. Alright Sean, over to you.
Thank you. So here's the real robot. I'm going to take the terminal and open ROS 2. And I'm going to open a save configuration. I'm going to open a second terminal.
Alright.
The source. I'm going to launch my localization and my map that I previously created.
Okay.
There it is.
Alright.
Then I'm going to open another terminal. Source. Oops. I'm going to open yet another terminal. I'm going to teleop around and get my. So if I do this right now, if I go to 2D pose, estimate my pose. There it is. So it has the map kind of off, so I have to teleop now around and get my map work right. Let me check out RViz. The RViz is close now.
Okay.
All right, so now I will, I'll create a YAML file. Let me go into here. Here's my, I'll create a YAML file very similar to this. Let me just delete this. Let's start over. Okay.
So can you just explain what the YAML file you're creating will be used for as you do it?
Can you say again?
Can you just explain what the YAML file that you're creating will be used for as you do it?
The map file?
The YAML file that you're creating.
Oh, the YAML file.
Yes.
So it's easy to store data and information, so I can create points and store the orientation and the position of the robot, and then it's easy to grab that from another file, another Python file from the YAML file. So just need a convenient way to store data.
Alright, okay, alright.
Okay, so now I'm going to see if my 2D goalpost works. Let me just run, just see if it. Oh, whoops.
So are you still trying to get it to align with your original map to get it to the right pose?
Yes, there it is.
Okay,
So
there
now
we
I'm
go.
going to create the points now. I'm going to run the server for the file for saving the spots.
Okay.
So we'll go to corner 1 first. Let me just get it there. Not working now. Hold on, let me
So you're gonna go to corner 1 so you can save that spot in your file, the coordinates of it.
hold on, let me just. Okay. I can tell the app again.
Okay.
Okay, so went to that position. So we'll record that one as corner 1.
Mm-hmm.
Okay, so that worked. Then we'll our visit to the next corner. What's going over there? Call that corner 2.
Okay.
And then we'll our visit to the pedestrian crosswalk, or approximately where it's at.
Okay.
And in the center too. Get right there. Okay. Then when I call end, it saved the file.
Okay.
We'll take a look at that file. So now if I go down here to my code, I have a real spot.yaml. I can grab all this and put it into my YAML.spots. So I'll just comment all this out. This is a test from this.
Okay.
Okay. Now I'm done running this one, so I can stop that. All right. And I can do source install setup.bash, and I can do I have to build, so hold on, build packages select project page. Okay. Then I have my go to spots. Take a look at that. Launch PyFile. So if I go down here now, he's in the center. So I'll launch him to corner 1.
So are you trying to get it to go to corner 1 using this?
Ending goal for spot corner 1. Even for result. Hold on. It's work for it. Let me just see. Something else is.
Can you try sending it using maybe RPs, and let's see.
I'm just trying to get it to move right now.
Alright.
There it goes.
Okay.
So my computer is a little slow. I'm sorry. There
Alright.
it goes.
So it does move when you do telop. Can you try sending the goal with RPs? Oh, there we go.
Just going to the goal.
I see. I see. Okay, that's good.
Let me just do it. So if I let me get it with our
Try with RPs and let's see if it responds.
Okay, let me see how that looks.
Alright, it's almost there. Can you still see it? Let's see. Oh yeah, there you go. Right.
All right, so from this corner, I'll try to go to the other corner real quick.
Alright, let's see how many more minutes you have. You've got about 3 more minutes. So
Here it goes.
Okay, there we go.
Okay, so navigation result received.
Alright, wonderful, wonderful. Can you now take us through how you managed to get it to do this, your code base?
Yeah. So I did my project mapping. So I have a config with the Lua file. I have a launch and teleoped around. I created the map, and then I did next. So that was project mapping, and then I had project localization to localize it with an AMCL file, adapted Monte Carlo localization config. Which looks like that. And then in my project localization, I have my go to spot, and well, first spot's the file, which
I see. Can you explain a little bit more how you...
AMCL pose, and it creates a service save spot. And I have re-entrant callback, so it does both threads, the post callback and save spot callback at the same time.
Okay.
It's looking for an end, so it can save as many spots as you want in the YAML file, and then it saves the spots when you receive the end signifier.
All right.
The YAML file. I go to spot. Just basically grabs that YAML file and looks at the first name, whether it's pedestrian or corner 1 or corner 2, and grabs all the position and orientation information from it, and then it moves it sends the goal and does the pose through the project path planning, and wait for a response back. And that's project path planning.
Can you explain a little bit more how you managed to get the map, right? So you mentioned something about map creation, right? Can you take us through that part of the project? How did you do it?
Map creation?
Yes.
Sure. So I followed I did the ROS2 navigation, and we created a Lua file, so I can show you that. which basically it's looking at all of the laser scans and stuff like that, and it's creating a map as you teleop around. And that and use sim time, cartographer. So we use cartographer, not slam toolbox.
Okay, what is the relevance of cartographer? What does it do in this case? Why cartographer? What does it do different as compared to slam, or why did you
Well, because it just focuses on building the map, so we're trying to keep it simple and not do slam simultaneous localization and mapping. We're just building a map and then localizing it to an already saved map file.
Alright, so in the process of that, you did make use of an occupancy grid, right?
Yes.
And what is the importance of using an occupancy grid during the process of that mapping?
That divides where it's searching and exploring. It divides it into sections, into a grid.
Alright, I see.
Saves the points and stuff like that.
Alright, so in the process of mapping, right, you make use of the MCL node, right?
Yeah.
Yeah, what is the importance of the MCL node? What does the algorithm do during the process of localizing the robot?
It's looking for probabilities. Adaptive Monte Carlo localization is an algorithm that is it's doing Bayes theorem on points and coming up with a probability of where things are.
So in this case, when you say things, are you referring to where the robot is or where every other thing in the map is?
Both. Not where. So we're teleoping the robot, so we're not doing localization of the robot in the map yet. But we are looking for where everything is in the map with the lasers.
All right. So to the AMCO, you pass one of the parameters is number of points, right? That the map that will be dropped on the map when you want to localize the robot, right?
Right.
How many points did you choose, or how many points would you choose if you're going to do a global localization for your robot?
For the particles, I did 500 to 2,000, the standard.
Okay. And how did it work when you used less versus using more?
Well, if you use more, it does like global navigation, and my computer really slows down. And if you do less, you get less accuracy.
So that means less accuracy on where the robot is that right?
Right.
Okay, I see. Okay, then after you do that, let's say you've created your map, the process of saving the map itself, can you take us through that? And where exactly do you
Say it
save
again.
that map?
After map serving.
Yes, how does that work? How do you save your map, and where exactly do you save
So
it?
I have it here, my project localization. Let's see. I launch it. So the package is nav2 map server, executable map server. I use SimTime, and the map file saves as a YAML file.
Alright, I see. Alright, let me see if I have any other questions for you. How else would you send a goal to your robot, right? Let's say in these two cases we used the YAML file and we also used ROS. How else would you send goals to your robot?
Right.
What's the third method that you can use to send a goal?
Say it again. What's the what?
What's the third method that you can use to send a goal to your robot?
The different methods?
Yes.
Well, you could either you could do it on the command line. You could send a goal. You could programmatically do it. You could do it with RViz2. You could I did it programmatically and with RViz2. You can do it from the command line.
Okay,
You
yeah.
send a goal.
Yeah, those three. Those are the ones that I was trying to get. All right. Do you have any other parts of your project that you'd want to show?
That's pretty much it.
All right. All good. Nice project. And I think we'll wrap it up here, and then I'll finish our conversation also. All right.
Okay.
All right. Alright everyone, so this was Sean's presentation. We do encourage you, if you want to have a go at one of the courses we offer certifications on, would highly encourage you to do that. And then until next time, keep pushing your ROS learning. Bye bye.